In this problem, we're told that Dennis went cross-country skiing for 6 hours on Saturday. He skied 20 miles uphill and then 20 miles back downhill. And returning to his starting point, his uphill speed was 5 miles per hour slower than his downhill speed. We're asked, what was Dennis's speed going uphill and his speed going downhill? So let's say he's skiing on flat land. We'll go ahead and we'll call that his rate. So R equals his rate. And what are we told? We're told he goes 20 miles uphill and then 20 miles downhill. So both of these are 20 miles. And we're told that as far as his rate is concerned, his uphill speed was 5 miles per hour slower than his downhill speed. So let's call his rate going uphill R. And actually, we'll go with his rate going downhill being R, because that's kind of how it's stated in the problem, since we're told that uphill is 5 miles per hour slower. So we know that both of these are 20 miles. So that's our distance. And then his rate uphill is going to be his rate downhill, which we've defined as R, minus 5, because it's 5 miles per hour slower. And then his rate downhill is just, as we said, R. So now we'll set up our chart. Remember, this is uniform motion, so we're looking at distance equals rate times time. So we'll have, let's go ahead and have uphill and downhill. And we're looking at rate times time equals distance. So his rate going uphill is R minus 5. His distance is 20 miles. Downhill, his rate is R, and the distance, again, is 20 miles. And so time, since it's rate, distance equals rate times time, we know that time equals, I'll go ahead and write it to the side instead, time equals distance divided by rate. So if we put that into our chart, our time is 20 over R minus 5 and 20 over R. So now again we have distance equals rate times time. But what else are we given in the problem? We're told that he went cross-country skiing for 6 hours. So we know that the total time is 6 hours. So what does that tell us? That tells us that both of his times added together, is uphill time and downhill time, are going to be 6 hours. So we have 20 over R minus 5 plus 20 over R equals 6. Multiply both sides by the least common denominator, which in this case is going to be R times R minus 5. When we distribute this, with the first term, the R minus 5 is going to cancel, and we're just left with 20R. With the second term, the R is going to cancel, so we're going to have 20 times R minus 5. And that equals 6 times, distribute the R squared minus 5R. So simplifying further, we have 20R plus, distribute the 20, 20R minus 100 equals 6r squared minus 30r. Combine like terms, we have 40r minus 100 equals 6r squared minus 30r. I'm going to go ahead and move everything over to the right, so we're going to end up with 0 equals 60r squared minus 3r minus 40r. Oh, excuse me. I said 30r, but I wrote 3r. So 6r squared minus 30r minus 40r is minus 70r. And then plus 100. So if you notice, we have some common factors in here. Excuse me. So we will go ahead and we will factor out a 2. 6 divided by 2 is 3r squared minus 70 divided by 2 is 35r, and then plus 100 divided by 2 is 50. And again, that equals 0. So we want to know, are there will this factor, do we have a factorable polynomial now? And again, if you don't remember how to factor this, I'm not going to go through the ins and outs here, but you can go back to the sections that we've gone over involving factoring. We could use the rational roots theorem. We could factor by trial and error. Once you do those methods, however, once you perform those methods, you'd see that this will factor into r minus 10 times 3r minus 5. So that gives us r equals 10, or r equals 5/3. Now, there's something we should notice about this. When we're looking at the nature of our problem, we're told that r, or what we defined r as, is the rate downhill. But we're also told that his uphill speed was 5 miles per hour slower. So our answer has to be greater than 5, or he would have a negative speed. So he'd be going downhill even though he's going uphill. Since r equals 5/3 is not greater than or equal to 5, that cannot be an option. So we are looking at now that Link's speed downhill, Dennis's speed downhill is 10 miles per hour, and his speed uphill is 5 miles per hour slower than that, which is 5 miles per hour. And if you put those into the original equation, it will satisfy that equation. That's how you would check the solution. So when Dennis went cross-country skiing, it took him 6 hours total, and his speeds were downhill 10 miles per hour and uphill 5 miles per hour.